This video is for class 8 physics, and in this video we are discussing about light energy from chapter number 5. So let us start with the first topic from your book, which is speed of light in different media. So coming to the topic, speed of light in different media, here the word media is the plural of medium, right, through which the light is traveling, through which the light is passing. So it can be like air, water, glass, plastic, right, any transparent medium. In class 7 we have read that light travels faster in air than in water or glass. The speed of light in air is 3 into 10 to the power 8 meter per second, whereas in water is 2.25 into 10 to the power 8 meter per second, whereas in the glass it is 2 into 10 to the power 8 meter per second. Here you are noticing that the speed of light is decreasing as the medium is changing, right, from air to water to glass. So in the language of physics we say that glass is optically denser than water and water is optically denser than air, or air is optically rarer than both water and glass. So this optically rarer or optically denser depends upon the speed of light. Thus a medium is said to be dense if the speed of light in it decreases, while it is said to be rare if the speed of light in it is increases. But in no medium it can be more than 3 into 10 to the power 8 meter per second. So it cannot have a value of speed of light more than this particular value. This is the maximum speed with which the light can travel. So I hope you understood the first topic, which is the speed of light in different medium. Let us go to the next topic, which is the refraction of light. So refraction of light, light travels in a straight line, right? We studied this in class 7 in a medium. But when a ray of light traveling in one transparent medium falls obliquely on the surface of another transparent medium, it travels in the other medium in a direction different from its initial path. So this can be explained with the help of a diagram, then with the help of one experiment, right? So basically here the particular paragraph wants to tell us that suppose we have a water surface. Suppose we have water surface, right? Here we have water, okay, and suppose we have air molecules as well on the top of water. So we are having two different media. One is air, so this is air, whereas this is water, right? So whenever light ray is traveling from air to water or water to air, okay, such that it strikes obliquely, that means making some angle with the surface of this particular surface of water or any other medium, then what happens, the light is supposed to go straight, but it does not go. It tries to divert from its direction, right? It tries to divert from its direction. This particular phenomena is known as refraction of light. Here the lines are not straight, but it is supposed to be straight. That can be explained with the help of a proper diagram given in our book. Thus the change in direction of path of light when it passes from one optically transparent medium, remember it needs to be transparent, one optically transparent medium to another is called refraction of light. It has been experimentally observed that when a ray of light travels from a rarer to a denser medium, say from air to water like we have seen, or from air to glass, it bends towards the normal. Now what is this normal? We have to understand after some time, okay, as shown in the figure. Now here you can see this figure, this is a proper figure, okay, than what I have drawn. So here so here we are having a figure where a light ray is traveling from air to water. It is traveling from air to water. Now here you can see when the light ray comes from air, right, this ray strikes this surface is known as surface of separation. Surface of separation, right, because this surface is separating two different media, that is water and air. So whenever a light ray strikes the surface of separation such that it makes some angle with the surface of separation here, right, then other than 90 degree, okay, other than 90 degree, make some angle other than 90 degree, then the light should have gone straight. But what happens is the light is bending, right, and this particular line is known as normal. This is an imaginary line which makes 90 degree with the surface of separation. Imaginary line which makes 90 degree with the surface of separation, right. So this particular phenomena is known as refraction of light. So this is when the light travels from rarer medium to the denser medium. Now coming to the next figure, or the point number 2. So when a ray of light travels from a denser to a rarer medium, when a ray of light travels from a denser to a rarer medium, say from water to air or from glass to air, it bends away from the normal as shown in the figure, just opposite of the previous one. Here the light is traveling from water or glass to air. So what is happening, the light would have been gone straight if there was no surface of separation. Now because of this surface of separation, you can see the light, the refracted ray is bending away from the normal. Now this is the normal, right, this is the normal. So this ray is bending away from the normal. In our previous case, it was bending towards the normal. It was going towards the normal. Here it was going towards the normal. Now in our second case, it is going away from the normal. It is going away from the normal. So both the cases are of refraction of light, okay. So here we studied that whenever the light ray passes from one transparent medium to the another transparent medium, the light ray changes its direction, and this phenomena is known as refraction of light. And the other 2 points which we have studied are, number 1, whenever the ray of light travels from a rarer medium to a denser medium, the refracted ray or the ray in the second medium is bending towards the normal. And the second point and the last point which we have studied till now is whenever the ray of light is traveling from a denser to a rarer medium, the refracted ray or the ray in the second medium it tries to move away from the normal. So the third case now, when a ray of light falls normally on the surface separating two media, it passes undeviated, that is along the same path as shown in figure 5.3. So let us go to figure 5.3. So here this is figure number 5.3. Here you can see whenever the light is passing straight, okay, such that it is coinciding with the normal. If I have drawn a normal like this, a dotted line, okay, this incident ray, okay, this ray strikes or overlaps the normal before striking the surface of separation. So under this condition, no refraction is taking place and the light goes straight. Fine, the light goes straight. So I have done one experiment, okay, with the help of a glass slab. You can watch that experiment now and then see these conditions, okay, see these conditions of refraction of light. As you can see, there is a glass slab here, right, there is a glass slab here and there is a laser light here. Now when the light comes out of the laser, it is traveling in air, right, and then when it passes through the glass, this is glass, right, so the light should bend. If I draw a normal which is an imaginary line, the light should bend towards the normal, right. So let's see what happens. So as you can see, when the light ray is traveling, okay, it is bending towards the normal. So I hope you have understood this. Okay, so you can see here the light ray, incident ray, right? This ray here strikes the surface of separation here. So then it is bending, it was bending this way, right? So now here in this case, when the light ray is striking such that it is passing to normal, it goes straight, it goes straight. So I hope you have understood this particular conditions for the bending of light. Okay, so let us go to the next topic. Okay, note, when a light ray passes from one transparent medium to the another transparent medium having the same refractive index. Okay, there's a new term which is coming, refractive index, right? So here this refractive index is actually, I'm writing it here, is the property of the second medium, right? Of the second medium, right? Which decides how much the light should bend. How much the light should bend. How much the light should bend. So I hope it is clear, right? So the property of the second medium which decides how much the light should bend, either towards the normal or away from the normal. So I hope you understood what refractive index is. We have to do this in detail afterwards, and in more detail in class 10 also. So it also remains undeviated. That means there are two conditions of no refraction taking place. So those two conditions are, number one, when the light ray passes straight, okay, this way passes straight such that it makes 90 degree with the surface, and the second condition is both the mediums refractive index should be same. Refractive index should be same. Index should be same. So I hope you are understanding this. Okay, so going to the next topic, some terms related to the refraction of light. For this we need a figure, okay, which is figure number 5.4. let us discuss one by one and then relate it with the figure. Okay, let's understand with the help of a figure also. So now the incident ray, the ray of light which falls on the surface of separation, okay, that is the surface separating the two media is called the incident ray. Okay, so let us see in the figure. Okay, let us see in the figure. So here we are having the figure, this ray which comes and strikes the surface of separation is known as incident ray. The next topic, okay, you can follow your book. The next topic is the refracted ray. Here it is written refracted ray. So the refracted ray is the ray of light traveling in the another medium or the second medium after it has changed the direction, is called the refracted ray. Here you can see this ray has changed the direction, right? It is moving towards the normal. Its original direction was here, right, the initial direction. Okay, so this ray in the second medium which has already changed its direction is known as the refracted ray. So I hope you have understood the incident ray. I hope you have understood the refracted ray. The next one is normal, which I have already explained also earlier. A normal is the perpendicular drawn on the surface separating the two media. So this is the surface separating the two media, and this is the normal which is done perpendicular. That means which makes 90 degree with the surface of separation, right? And so that at the point where the incident ray strikes, so that means this incident ray is striking here. Okay, it also has a name known as the point of incidence. Okay, this point where the incident ray strikes is known as point of incidence, right? So and this normal needs to pass through the points of through the point of incidence, making 90 degree with the surface of separation. Suppose the light ray had struck here, then I should have drawn a normal at this point only. For example, suppose the light ray strikes at this point, okay, so normal should be drawn here only, normal should be drawn here only, okay, not anywhere on the surface, not here, right. It needs to be drawn on the point of incidence, and the second condition is it needs to make 90 degree with the surface of separation. So I hope you have understood this particular terms. Okay, now let us understand few more. The other term which is given in our book is angle of incidence. So in the previous diagram I showed some angle here. Okay, I was just telling that the light should strike making some angle with the surface of separation, but we are supposed to learn this angle here, and this angle, the angle formed between the normal and the incident ray, is known as the angle of incidence. Whereas the last term which we need to understand is this angle here, which is the angle formed between the normal and the refracted ray. Okay, this angle is known as the angle of refraction. So I hope these few terms are clear. Okay, so there is another figure also just below that. If you can see here, there is just another figure also. You don't have to go all through all these things. Okay, whatever I have explained, that is enough. So here also you can identify which is the surface of separation, which is the normal, which is the incident ray, which is the angle of incidence, which is the refracted ray, which is the angle of refractions, etc. So I hope you have understood all these terms. Okay, so now we are going to the next topic, which is the laws of refraction or Snell's law. So laws of refraction. So refraction of light obeys following two laws, also known as Snell's law of refraction, also known as Snell's law of refraction. Okay, so let's see what are the laws. So coming to the laws, the incident ray, the normal at the point of incidence, and the refracted ray all lie in the same plane, all lie in the same plane. The incident ray, the normal at the point of incidence, and the refracted ray all lie on the same plane. And number 2, for a given pair of media and a given color of light, the ratio of the sine of angle of incidence I to the sine of angle of refraction R is always constant. So here this sine I and sine R, this sine I and sine R are trigonometrical operators. Okay, so this you will understand when you do trigonometry in mathematics. Okay, so the ratio of this value and this value is always a constant, right? It always a constant. A constant is also a number. For example, suppose the value of angle of incidence is 20 degree and the value of angle of refraction is suppose 10 degree, right? For suppose the light is traveling from air, right, to water. Suppose the light is traveling from air to water. So under this condition, whenever the light is traveling from air to water, okay, the sine of 20 degree upon the sine of 10 degrees should give me some value. Okay, suppose it gives me suppose 1.2 something like that. Okay, it will always come 1.2 only if I change the angles. If I change the angles also, it should always come 1.2 degree. If I change the angle of incidence, the angle of refraction will change automatically. So whenever we try to calculate this particular value, it should always come the same, right? So if I have taken 1.2, it will always come 1.2, right? If it comes 1.2, sorry, not if I have taken, if it comes 1.2 earlier, it will be 1.2 for all the cases whenever the light is traveling from air to water, provided the color of light is same. Okay, now this constant here is denoted by a symbol mu, right? This constant here is denoted by a symbol mu, and this is known as the refractive index, which I have explained just a few minutes before. This is known as refractive index, right? Refractive index. So this mu is refractive index. So this constant is actually given a name which is known as refractive index. Refractive index. So indirectly this is the formula for refractive index of which medium? Of the second medium, with respect to, that means with compared to the first medium. For example, if the light is traveling from, again let us take the example of air to glass. Okay, suppose the light is traveling from air to glass, right? So what happens is, if I want to calculate this, I will get a refractive index. I'll get refractive index of glass when compared to air. Suppose the value comes 1.5. Suppose the value comes 1.5. If I change the medium, suppose now it is traveling from water to glass, suppose now it travels from water to glass, it will not come 1.5 because the medium has changed. So this time it becomes the refractive index of glass with respect to water. Okay, and the value should come same. So if the medium changes or if the color of light changes, the refractive index should come same after the calculation. So I hope you have understood till here. This is known as the refractive index of second medium with respect to the first medium. It is given as mu, which is the speed of light in the first medium divided by the speed of light in the second medium. This is the another formula of refractive index. The previous formula was sin I upon sin r. As we have not done trigonometry, so I don't think so we will do any calculations from this formula. We shall do it in class 10, but we can do the calculations of the refractive index with the help of this formula, which says refractive index is equal to the speed of light in the first medium divided by the speed of light in the second medium. That means if we know the speeds of light in two different mediums, we can take out its refractive index, the second medium's refractive index. For example, if a ray of light travels from air to water, then the constant mu can be calculated by knowing the values of sin I and sin r. Is the refractive index of water with respect to air. It is given as sin I upon sin r. Okay, thus they are using the another formula, the speed of light in air, that is 3 × 10⁸ meter per second, which we have studied in the first paragraph, and sin r, which is 2.25 × 10⁸ meter per second, right? So this is the speed of light in water. Thus by dividing these two numbers, I shall get 4.3 or 1.33. Similarly, if a ray of light travels from air to glass, then the refractive index should change because the medium has changed. Initially it was air to water, but now it is from air to glass. So in this case, I am supposed to use the speed of light in air because it was traveling from air to glass. So therefore these values are different here. I am using the value of speed of light in glass. So in this case I am getting a different value, which is 1.5. So other thing which you can notice here is the denser medium, optically denser medium, will have more refractive index compared to the optical rarer medium. Note the refractive index of air is 1. So no medium can have refractive index less than 1, provided the light is traveling from rarer to denser medium. Provided the light is traveling from rarer to denser medium. But if it travels from denser to rarer medium, then in that case it can be less than 1. Okay, so I hope you have understood till here. One part needs to be explained, that is this part here. Okay, the incident ray, the normal at the point of incidence, and the refracted ray all lie on the same plane. To understand this, let us try to go to an image. Sorry. So we have come to an image. Here you can see, let me zoom this picture a bit. Okay, here you can see this is the incident ray, right? The incident ray. Okay, the incident ray is coming, and this should be its original path, but it is bending because of the refraction of light. Okay, so this is the refracted ray. Fine. Suppose if I want to draw a normal, I am supposed to draw a normal at this point, right? So this becomes your normal. So here this time the light is traveling from a rarer medium to a denser medium, right? This is air and this is glass. So the first law says that the incident ray, the reflected ray, and the normal, right, at the point of incidence, so this is the point of incidence here, at the point of incidence all lie on the same plane, so they are all lying flat on the screen, right? Now here you can see they all are lying on the surface, okay, on this surface here, flat surface here, right? So they are all lying on the flat surface, so the surface of your mobile screen. So